Hello again. You're listening to the Arax podcast from the maritime shipping and ocean news site Fathom World, and I'm Craig Eason, editor of Fathom World. So here we are now, coming towards the end of May, and suddenly it's getting busy. As many know, as well as managing Fathom World and putting together this podcast, and this is its 69th episode by the way, I earn my bread also by moderating industry events, and at the end of May I'm going to be in Brussels for the closing conference of the EU-funded SkillSea project, which has been working for the last 3 or more years on strategies to ensure maritime training in Europe is competitive and fit for purpose. Then early June I'll be in Oslo for North Shipping, where you can find me from Tuesday the 6th to Friday the 9th interviewing a range of industry experts on the Blue Talk stage at the Lillestrøm Exhibition Hall. Now, in line with the SkillSea theme, one of the Blue Talks I've designed looks at how we can get enough people interested in the industry, both to go to sea and to take the much needed shore-based roles. And then on the Friday of North Shipping, it'll be the Ocean Campus stage, talking to the training establishments about how they take the responsibilities of having people fit for purpose on the ships of the future. And talking about the ships of the future, there's 2 key spheres of conversation I've been having for many years: the new engines for the new fuels and the digitalisation of the industry as AI brings in higher levels of autonomy. Now, in terms of engines, there's another big event in June, and this one is in South Korea, in Busan. It's the CIMAC Congress, where one can get to hear about some of the latest research into technologies for shipping, as well as experiences in using some of those new fuels and ancillary technologies. Fathom World will be there. Gavin Lipseth will be joining me in a few minutes to talk about the Congress and what he expects us to be able to find out about the state of shipping technology. And then the other sphere I mentioned is digitalisation. And with this, there is the work to look at how maritime autonomous surface ships, or MAS, will emerge into the industry. Now, one of those Blue Talks in Oslo is on the latest developments in MAS and autonomous systems. You see, one of the questions I've had and others have had over the years is whether it's likely that we will actually see autonomous and unmanned ships in our lifetime in international trade. To help me with the talk is Hideaki Ando, who's going to be giving the opening presentation. He's from Monohakobi Technology Institute. It's a research lab owned by the Japanese shipping giant NYK. Ando and MTI are part of a big Japanese consortium, and it's a project funded by the Nippon Foundation, DFFAS, designing the future for full autonomous ship. It's a project that's part of the Maguri 2040 programme, and the reason for this programme is somewhat prosaic in my mind, because it harks back to that other topic I mentioned. There are far too few youngsters seeking maritime careers in Japan, a country made up of many islands and a huge domestic shipping industry. And in this domestic shipping industry, more than half the crew are over 50 years old. The desired solution is to reduce the crew and automate the ships more. The programme has 5 consortia trying to achieve 5 different goals, and one of them was the ability to sail a vessel autonomously from one port to the other. So here's Hideaki Ando from MTI talking to me about the trial that they had a year ago, their future plans, and a little bit about what we're going to be talking about in the Blue Talk.
We did a demonstration of our autonomous ship, a developed autonomous ship last year in the end of February and in the beginning of March. And that was a round trip from Tokyo Bay to Ise Bay. The distance is about like 200 miles one way. So the round trip is 400 miles. The vessel was a container vessel, and we retrofit the autonomous systems, autonomous navigation functionalities on container ship. That small container ships. It's a domestic coastal container ship. It's just a 100 TEU size. The size is 750 gross ton a ship. So it's very small ship. Actually, it's a retrofit, so the space and for the retrofit is very limited. So actually, we put all additional computers and equipments, many computer equipment in container box. So it is like all those electric equipments are installed and server in the server rack in a container. And also we place another container because this is demonstration. So several engineers from each manufacturers actually could work in that container box. And then, of course, we place several, of course, like human machine interface equipment and the display things in the navigation bridge. And then at the end, actually, could achieve actually in total, actually the average 98.5%, almost like 100%. Fully autonomous voyage, which
Okay.
means like, of course, we have regulations and so on. So still, the vessel is of course under regulation. So still the crews are on board and so on. But but crew did not touch, any equipment, instruments, but rather the system was navigating the vessel under the monitoring of the crews and captains. And that the 98.5% autonomous means like autonomous function is, of course, the system does lookout by using the radar and also like automatic identification by using the radar images. And so the vessel can identify all surrounding small vessels, other vessels, and also like the geographical constraints. Of course, that information is coming from electric charts. And so actually, the system automatically, autonomously, have a good, appropriate situational awareness surrounding the situation, and also the vessel system itself. Then, based on that situational awareness, and then of course, the long passage plan, voyage plan was actually originally developed before the navigation. So the basic waypoint and then the speed, actually, the plan was actually generated at shoreside at shore control center. And then once that is actually confirmed at the shore captain, then that the base navigation plan is sent to onboard system. And then, so based on that navigation plan, actually the vessel start navigation. But of course, this is actually navigate in very congested areas, such as like a Tokyo Bay, as you're familiar. Then the vessel itself, autonomous system itself, detects the surrounding vessel, block the course. Then actually the computer run the first-time simulation to find collision avoidance routes. And then the computer itself actually automatically approve the new plan, new passage plan. Then it follows the new waypoints to avoid the risk of collisions. So then it continuously iterating that kind of like the route updates in this congested area. It's actually that update is more than 100 times. Then it actually somehow avoid the risks, and then it navigate safely in that congested Tokyo Bay, and it go out to the ocean.
I mean, obviously that was a coastal voyage within Japanese waters, so there was only the Japanese authorities and classification and regulators that actually had to take to say yes to give the dispensation of that, and it was a relatively short voyage on a smallish vessel.
Right.
So where are you going to take this next? What's the next endeavors going to be to develop this?
Well, I think we are considering two directions. The first direction is still, we continue this because we have achieved some level, but that is the technology is just for demonstration. So it does not mean that we can daily use in the real operation. So we need more robust, stable, and reliable equipment, which seafarers can believe in the technology as the ordinary and reliable equipment. So there is a still gap to make the technology improve the level of the technology to the ordinary use. So that is one thing. And then, actually, we are now concentrating on the still small coastal ships to achieve autonomous system to support human operations. For the demonstration, actually, we installed that all equipment in container box actually in the end of November. Then after November, actually, all the captains and the crews were like experiencing with us about like a testing and like commissioning testing, and then some trials. Then in the end, actually, we ran the demonstration in the beginning of March, in the end of February. So which means like the captains were staying with that autonomous system about like 3 or 4 months. So actually, within that period, actually, those captains, crews were so get used to using that kind of equipment. It's very helpful for them. So actually, when actually all those demonstration was done, actually that project period is almost over. So actually, because that project was run by the found from the Nippon Foundation. So actually, anyhow, in the end of the project, we have to discharge all those equipment and so on. But actually, the captain was asking us like, please leave all those equipment because we are so get used to this and we like this equipment. So please leave it. So that was a very good message from the captains. So very excellent feedback we received. So at the next stage, we hope that we will provide them the real equipment and the functionalities which help their daily operation navigation work. So that is what actually now we are working on, that we try to achieve maybe within like 3 or 4 years. And then at the same time, same functionality, of course, support bigger vessel operation like ocean-going deep sea vessels too. We are MTI are part of NYK, so actually we are now working with NYK to how we can bring experiences in a coastal vessel to deep sea vessel. So then actually again, we have to identify what is the concept, how the human operation supported by computers. So that, and then how that technology should be trained for crews, and so all those definition of the requirements to the technology, and also the how we can utilize that technology with human crews, and then how we need to, and what is the necessary process to utilize that, use the technology, and then we have to educate and so on. So all those things have to be well considered before developing something. But still, probably we are missing like a big good like a business model or business cases it's so that is still, I think, how the service provider, technology provider can be profitable in this autonomous ship implementation is actually still, everybody is still struggling to find appropriate business use case.
What's the biggest obstacle to that? Is it like the cost of connectivity, or is it the cost of insurance?
Oh, that is very. This is of course very difficult question. But actually, by having that technology on board, then who will benefit is still not very clear. It is for ship owner. It's just additional cost, investment cost. And operators actually don't care much actually about the autonomous technology. So it is rather more and more like a ship management company and also like a ship owner side issue. This is very much relating to the crewing and so on. In my personal opinion, I think if we can, for instance, like a bigger shipping company like NYK or could be Shell or others, if they can, improve the level of safety, like they can reduce the incidents or the near miss or those risks in their fleet operation of like 100 vessels or a couple of hundred vessels. Then, if they see that is a value, then probably this technology will go. So that is actually probably we are very close, and also technology level is now going better and better. So I think sooner or later, some ship owner find, oh, this will enhance our safety, and that will be probably bring some value to the operator or cargo owners, or customer or society. If some ship owner believe in that, then probably it may happen.
Does onboard autonomy, like you were demonstrating on the small vessel,
Right.
because you said you had all the servers in a container on the deck, but did you need high levels of connectivity with the shore for an autonomous system, or is the thinking that the autonomous system will be on the ship and therefore you don't need high levels of broadband connectivity, you can just have emergency connectivity when needed. I'm just trying to get an understanding of whether the idea of an
Yeah.
autonomous ship is that it's connected permanently to the
Mm-hmm.
shore via a
Mm-hmm.
satellite or through a 5G or other
Mm-hmm.
network, or whether
Mm-hmm.
the vessel and the crew would be truly autonomous. Both of them would, the vessel and the crew would be autonomous.
Mm. Okay. Yeah, that is, I think, a very good question. And also, actually, it depends on what kind of concept you have. But actually, in our demonstration, it was requested to develop a fully autonomous ship functional functions in that demonstration, which means like if something happens, actually, which means like we cannot expect crews or onboard crews to complement the to adapt to whatever situation. But so then, if there is no crew on board with that assumption, then actually, if something wrong happens, then actually we need some support from shore. So that's why actually you place shore captain. And then, so actually, we call it is actually remote fallback, which means like the computer, actually centralized information management system are gathering all information from each subsystem, and all subsystem condition is good enough. Then actually, which means like this is very healthy situation, and autonomous all necessary all subcomponents are working properly. But in some situations, for instance, it's like a very congested or like it's external by external situation, then this is actually it could be also degrade the level, like need some attentions or some from somebody, a supervisor's attention is necessary. Those cases actually centralized information management system judge, okay, now we need to pay attention. So then actually that system level is a bit one level up to like a higher alarming level. For instance, like some system, the functionality like a sensor is the reliability is degraded, and then actually the system identify themselves. Oh, my system itself is actually not very in good condition. Actually, we cannot rely on very much our eyes or something like that. So then, depend upon such an integrated status. Actually, in the third stage is actually third worst stage is actually we need a remote fallback, which means like a remote monitoring by the shore captain, and in some cases the shore captain can take control. So that is what actually our definition, our concept were defined. So actually in those cases we have to fully rely on satellite ship-shore communication. So in this system case, actually, satellite communication is so critical. So if that is lost, actually remote fallback cannot be achieved. So then actually that will be go to the final very worst stage, like an independent fallback. So which means like a onboard system has to take control by system itself, or in our case, actually, still it was a demonstration, so the captain was on board. So then captain, which means like a captain in independent fallback status, actually captain have to take over the all control. So that was 1.5%. Actually, the captain took over the all control from the system. So that was independent fallback. So if you define your system much relying on the shore operation, continuous shore operation, then it is the ship shore satellite communication is critical. Now, actually, that time actually we use VSAT communication, and also we combine with terrestrial communication. So we try to select the faster network, available fastest network among several channels. Actually, the terrestrial communication was not very stable, and also sometimes the VSAT satellite communication, we lost like a connection to the satellite and so on. So actually, not very frequently, but sometimes we lost that the ship-shore communication in the demonstration. Then next that time, actually, we cannot again we could not do the remote fallback. So actually, if we think about like the real implementation of this technology, then actually still this ship-shore communication is so critical. So even Leo and the faster satellite service will come, like Elon Musk, Starlink come or OneWeb come, but still we think that probably we cannot 100% rely on such a communication. Probably sometime we will lose the communication. So then actually it means like we cannot at this stage. Maybe in 10 years, maybe the situation will change. But at this stage, we cannot select like a ship shore. I mean, the shore-based control is actually almost we cannot design the system as so. Then probably demonstration is okay, but we cannot use for the the reliable or daily operation. We cannot rely on the shore control system.
That was Hideyuki Ando talking to me about the future of autonomous shipping, and he'll be joining me on the Blue Talk stage on June the 7th in Lillestrøm. And the other experts that are going to be there will be Erik Dyrkenund, the CEO of Cibus, Ivar Parlov, Associate Professor at BI, Margareta Lutstuft from Marsafe Group, and Sveinung Soma, the CEO of Remota, to talk about the realities of autonomous achievements in shipping and offshore.
At North Shipping, people come to find out what's new and, of course, meet up with colleagues and industry friends. It's also a perfect time to get updated. This year's North Shipping theme is partnerships. I'm Johan Matslin from North Shipping TV, and we'll naturally bring you plenty of insights on our digital television channel. Or, if you're actually at the exhibition hall for North Shipping, you can freely visit the Blue Talk stage and listen to one of the 12 talks on dedicated themes. Maybe you want to hear the latest about shipping competing for future fuels, about hydrogen and electrification, or perhaps you're keen to discuss digital connectivity and automation. Or it could be wind propulsion, onboard carbon capture, or offshore wind. Or maybe life cycle thinking, equitable financing of change, or the reality about green corridors. On the one stage over 3 days, there will be 60 experts on 12 themes, arguing with a seasoned journalist keen to uncover where the shipping and ocean industries are moving. Find the Blue Talk stage at the Lillestrøm Exhibition Hall, just outside Oslo, from the 6th to the 8th of June. Welcome to North Shipping 2023.
I mentioned CIMAC. It's the International Council on Combustion Engines, and its members are the engine makers, obviously, but also turbocharger makers, lubricant oil makers, and other engineering companies, but also fuel suppliers and the research institutions that innovate in this world of engineering. Now, normally every 3 years they have the CIMAC Congress, but because of COVID, it's been 4 years, and it's happening this year in Korea. And off to Korea is going Gavin Lipseth, our intrepid reporter involved in everything to do with heavy industry. So I've asked him to join me on the podcast this week to talk about CIMAC, because I think a lot of the stories that we talk about, Gavin, are relating to the evolution of the shipping industry, particularly when we're looking at new fuels and when we're looking at ammonia and when we're looking at methanol, biofuels, and all of these options are going. And we know that there are some key technology companies involved in there. So what are you expecting to see here at CIMAC when you go over to South Korea in June?
Hi, Craig. Yeah, thanks for having me on. As you said, the CIMAC Congress is really it's the 3-yearly get together, and normally it's a very intense conference, 4 streams that go out of sessions that go on for 4 days, and quite technical in some cases, ranging from basic research to engine development and service experience. There's a lot there that you can pick from. I think what's really interesting to me this time is, as you said, the alternative fuel developments. Because we're 4 years now since the last CIMAC, the decarbonisation agenda in shipping has moved immensely since then, and so has where we are in reality to some of the technologies. So, for example, methanol engines are now a very realistic prospect. You know, they're on merchant fleets beyond methanol tankers for the first time with Maersk's fleet of container ships. So one of the interesting things that I'm looking at, for example, is MAN are going to be giving some updates on the engines that will be in those ships that are coming online into service next year. In fact, the first one in September, and then the rest of the fleet in 2024. So that's one example. And then if you look at ammonia, a bit more of a distant project, and that's reflected in some of the papers in CIMAC when there's a lot more basic fundamental research into combustion characteristics, emissions profile, which is one of the relative unknowns at the moment. There'll also be discussions from the main engine developers like Wärtsilä and MAN about what they're doing and how their ammonia projects are coming on. But I just thought it was really interesting that the level of ammonia research that's still going on indicates that there's a lot of development still to come.
Yeah, I've seen that in a lot of the conversations I've had with the industry, where I see that there is a growing acceptance on the introduction of methanol into the industry, and it's going to happen for various reasons, and that ammonia seems to be, 5 or 6 steps back in that evolution chain, you could say. And you've seen that reflected in the level of the papers that are going to be presented during CIMAC.
Yeah, absolutely. If you look at some of the papers, not beyond the commercial companies who are talking about their product development, and obviously there's a little bit of marketing that goes on there, and they're talking about what's coming up. But if you look at the research institutes, the universities, which have a huge part to play in CIMAC, really, and kind of that's where you get the real understanding of where the innovation is coming through. Then you see what they're focusing on, and there's very much, as I said, looking at some of the emissions profile of ammonia, how you measure it, how you understand. Because obviously ammonia has never really been used as a fuel before, so understanding how it's going to look like when it's burned in an engine and what the emissions profile is going to be, and therefore what we need to do to tackle it. So obviously that goes side by side with just learning how to burn it. We also need to learn how to manage the waste products that come from it.
And another topic that's becoming very popular at the moment is carbon capture on board. Carbon capture, the idea that you continue using an existing engine style, but have the technology on board to capture the CO2 emissions coming out of the exhaust. It's seen as a high-profile solution ashore in large polluting industries that are going to need some sort of carbon capture and storage. But there's a lot of effort, there's a lot of research projects going into sort of marinizing and making the technology compact enough to go onto a ship. Is this likely to be a technology that's going to be given a lot of airtime during CIMAC?
So actually, that's one of the surprises for me, is that there's not more of this, because we've had some, as you said, we've had some very high-profile projects looking at carbon capture. The remarkable one comes to mind with ABS and on a Stena bulk vessel that was announced quite recently. I'm not sure if that's come into operation yet, but certainly in the preparatory stages. But no, there's not a huge amount. I mean, there's a couple of examinations of how scrubbers will possibly be adapted to capture both particulate matter. I think they already do, but to a greater extent, and actually carbon dioxide in the future.
I guess the technology for carbon capture is seen as a sort of evolution of the sulfur scrubber technology. It's the ability to take a similar sort of process but apply it in a different way for a different gas.
I think that's one of the options, and if that worked well, it would make sense, because we already have that technology working on board vessels. So for sure that would be probably the easiest drop-in solution if it's found to be effective. There are other options, but not nothing that's hugely well developed. There is another interesting specific paper that ties carbon capture in with LNG. As we know, LNG has got a huge uptake, slightly reduced emissions, maybe depending on whether or not you account methane and how you account for methane. So there's definitely, at the moment, it's a kind of, say, slightly reduced carbon fuel. Obviously, if you twin that with carbon capture, then you have the opportunity to reduce the emissions much further and make it a much more viable fuel in terms of long-term decarbonisation. So one of the presentations that I'm really looking forward to around carbon capture is from CMA Ships, part of the massive container liner CMA CGM. And they are looking at exactly that, how their huge investment so far in LNG could be decarbonised further using carbon capture, utilisation and storage. So I don't know much about that. I've not heard much from them in the past. So that's something new to me that will be at CIMAC and possibly interesting when you have an operator of that size talking about what they're looking at.
And what about the introduction of biofuels? Is this drop-in idea of biofuels or the evolution of different new fuels, is that something that the engine makers and the research institutions are also looking at?
Yeah, absolutely. I think, again, biofuels have been pretty widely trialled in shipping for the last few years. So there's going to be some interesting operational feedback on that, again, from CMA, I think, actually. But there'll be a bit more looking. I think there are certain issues that come with the storage of biofuels. Calling them drop-in fuels may be slightly optimistic, because I think there's certain issues about how they're used and how they're stored that can make them a slightly more challenging prospect than conventional VLSFO.
And what do you think are going to be the highlights for you being in Korea for that week?
In general, it's just getting an idea of where shipping's going and where decarbonisation is leading the industry in a realistic sense. As I say, there's just a lot of hype around some technologies, and some of them.
I think you're right. There's a lot of spin that I see coming through in press releases and announcements and running on the sort of meeting the challenge of decarbonisation. But the reality is that these engines are huge. They are massive beasts that have a lot of complex technology around them. And it's not easy just to switch out one to the other as if you're dealing with a car, for example. And
it's a huge investment.
It's a huge investment, but also it's the ancillary technologies that you've got that have to go around everything on a ship. You can't just stick in a new kind of engine, put a fuel tank and say, hey ho, here we go. It has to be a much more complex, and you look at the way that the engines are built even. So having all of this technology ready is going to be key to all of this, and knowing what you're going to do when, particularly in all the process. So have you seen much discussion in terms of how this decarbonisation works alongside the shipbuilding process?
That is a serious consideration. I think the way that ship design changes to accommodate alternative fuels is going to be huge, and obviously it's not just the engines, which are a massive investment that the ship owners have to be certain will be the right choice for the next 20 plus years. It's also the fuel tanks, which are going to need to be much bigger. Ammonia and methanol will need to be at least twice as big as the as tanks used to store VLSFO if they want the same range. So yeah, that's a huge challenge. And then when it comes to the type of tanks and where they're positioned, given safety regulations and the kind of structural reinforcement that's needed for tanks of that size and weight. So yes, very, very, very important things to consider. There is a really unusual paper in CIMAC that I'm looking forward to, which is from Damen, the Dutch shipbuilder, that is talking about exactly that. Now, I've only seen at this stage, you don't see the papers; they only give you the title, and the title says alternative fuel, or the impact of alternative fuel on ship design. So, but Damen are a big company. They've got a lot of experience in alternative fuels and on kind of a range of vessel sizes. So I'm looking forward to their input. It's the first time I've seen a shipbuilder talking about anything in CIMAC and I've been there for the last 3 times. So and there's Hyundai there, but I think more on the engine technology side than shipbuilding.
CIMAC is on in Busan in South Korea from June the 12th till the 16th. You're going to be reporting for us at Fathom World and hopefully giving some contribution into the podcast as well, live or as live maybe, from the floor at the Congress, talking about the let's just say what you find to be some of the most exciting and interesting things relating to engines in the future of the industry. So Gavin, thank you very much.
Pleasure. Thank you, Craig. Look forward to coming back on.
And don't forget that you can sign up for the newsletter from Fathom World. We put a newsletter out once every fortnight. Go to fathom.world and you can sign up there. Don't forget to subscribe, like and share this podcast. And you'll find Gavin, of course, in Busan between June the 12th and June the 16th, and you'll more than welcome to go up and have a chat with him. And for myself, I'll be at North Shipping. You'll find me in Oslo at North Shipping on the Blue Talk stage, where I'll be moderating all the Blue Talks there. Until the next time, thank you very much. Goodbye.